I thank the organizers for giving me this opportunity to make a presentation on the iconic structure that is a KANAKADURGA flyover at Vijayawada. So thirdly, I thank the student who gave a beautiful description about me. I thank you. God bless you. And I'll start my presentation. So this is a KANAKADURGA flyover is an iconic construction structure in and around us in the city of Vijayawada. We'll just go to the details and let us know how it is iconic and all those things. Let us start. So we're starting with a small video. No volume. Yeah, actually in that video we did not. We are not putting the volume because we may get the discussion. Okay. Yeah. So you can see the flyover being constructed. So on the banks of River Krishna, and a part of the flyover being constructed into the River Krishna, between River Krishna and the KANAKADURGA Temple Hill, and another side is Krishna Barrage, and downstream of that is Krishna Eastern Main Canal is there. So much habitation is there. So in between all these things, the flyover, KANAKADURGA flyover has been constructed. So it is just in our city, Vijayawada. So next thing is let us have about the details of the flyover. I just segregated like this. The contents of the flyover. First one is the overview of the project. That is the details of the project, and then comes the alignment. Then pre-construction activities before doing the actual flyover construction. Pre-construction activities are very important in constructing doing any project with respect to the state government. And then comes the flyover part itself, the foundations, substructure, superstructure, and how this superstructure has been constructed, like the segmental construction. And for doing the segmental construction, how the casting yard has been allotted, and the beds have been prepared. And after casting the spine and wings, how they have been, the launching has been done. So another exclusive part here is the extended Pier cap. So these components we will discuss for the interest of our engineers. First one is the project details. The total cost of the project is 502 crores. It's coming to 502 crores. It may increase a little bit when the final cost estimate is prepared. So out of that, the civil cost is 326 crores. So civil cost is 326 crores. So you may think that only the flyover is one that is done in this project. Actually, in this 326 crores, we have done apart from flyover. So many things have also been done. Just to make you to know about those. The components have been shown on the right side. You can see we have constructed a 6-lane flyover of 2.6 kilometers, and we have constructed a major bridge apart from the flyover. Just a major bridge opposite to the temple of around 261 meters. And apart from these two, we have constructed 3 vehicular underpasses. VUPs we call them, vehicular underpasses, for the movement of the vehicles beneath. And also one pedestrian underpass has also been constructed just opposite to the temple, so that the pilgrims or the people who took bath in the river Krishna, they can cross the national highway or the flyover without just getting onto it through this pedestrian underpass. They can cross and climb the hill to the temple. So for that purpose, one pedestrian underpass has been constructed. Apart from these 3 components of the structures, we have also done 5.3 kilometers road of national highway to 4-lane. Earlier it was around 7 to 9 meters width. We did it to 4-lane configuration of the national highway, including the central median, lighting, retaining wall, drains, shoulders, everything we did it. So all these components have been done in this project. So the agency who executed the project is Mr. Soma Enterprises Limited, Hyderabad. We entered the job in the work actually to authorities Mrs. R.V. Associates Hyderabad. Mrs. R.V. Associates Hyderabad are the authorities engineer. Means we are the authority, that is the R&D department is the authority. So on our behalf, one engineer will be working. He is Mrs. R.V. Associates. So the design consultant for the project is Mrs. AECOM India Private Limited. So from AECOM, one active guy is here by name Krishnakant. He is also a part of this presentation. So he has done the design part from A to Z. We can appreciate the slim sections of the flyover when we see it. So after they do the designs, one more proof consultant will be there who proof checks the designs. He is Mrs. Construma Constructions Mumbai, Consultants Mumbai. And apart from these two consultants, our authorities engineers also will scrutinize the designs. Then only it will be put to execution in the site. So the project is funded by both the Ministry of Road Transport and Highways and the government of AP. So this project is done on EPC mode, that is engineering, procurement and construction. Because that means the contractor has to engineer the project. So you know the specialty of an engineer. We do innovative things. Likewise, we give freedom to the agency. They have to design the slimmest sections, economical sections, what he can do, and he has to prove with respect to the designs with the design consultant, proof consultant, and our authorities engineer. Then he can execute the project. That is the engineering, procurement, construction mode. He has done the project. So that is about the project details. So next comes the alignment of the project. So the alignment is the alignment is passing through. You can see the superimposed on the Google map. You can see here. You can see this is the green one is the river, that is the reservoir upstream of Prakasham barrage. You can see the other side Hilaka, that is the KANAKADURGA temple, and then here it comes the Krishna Eastern main canal. Apart from that, the downstream of the Krishna river. So in between all these things, the alignment is passing like this. This red portion is the alignment of the 6-lane flyover. Beyond flyover, we have done the 4-lane at-grade road also up to KANAKADURGA Mavaradi. This is the alignment. Next slide. So this is the very aerial view of the alignment. You can see. So these are green circles here. These are the pump houses which give water supply to the city of Vijayawada. So being maintained by the Vijayawada Municipal Corporation, and so the full of habitation here. You can see the Krishna River. So this is the barrage, and this is the Krishna Eastern main canal here. So in between all these things, we have constructed this KANAKADURGA. There were some discussions that when some consultant has been given the DPR preparation, some consultants could not get the finalization of the DPR because of the habitation, hillock, river, and all those things. But finally, one company, Mr. Shaladia Insulation America, they have done the alignment, and they have submitted the DPR. And based on the DPR, the benchmark has been fixed and tenders have been called for, and the work has been executed as you see now. So because of the constraints occurring in the alignment, that is complete habitation there, and the pump houses and all those things, and the river and the hillock and the Krishna Eastern main canal, all those things, the flyover has to take a snake-like turn. You can see here. You can see there are 6 curves existing in this alignment. There are 6 curves. Normally you see, that's why I'm telling you it's an iconic construction. Normally you see a flyover constructed in a straight portion or one or two curves, but here the alignment has taken 6 curves. So this flyover is having 46 spans. Out of these 46 spans, 26 spans have been constructed in curves. Means for 26 spans, we did the design, execution, and everything as curve. So doing in a curve is different from doing in a straight portion. That you can appreciate when the subsequent slides are presented to you. So only 20 spans have been constructed in straight. So the other statistical data, what we can present here is we are having different varying spans. We are having spans of 45 meters, the 11 such spans, 42 meters, 5 such spans, 40 meters spans, 2 spans, 39 meters, 22 spans, and 36 meters, 6 spans. Apart from these, giant extended pier caps have been constructed. That is a span itself on a single pier. That is 16 meter spans, 6 such spans have been executed. You can see the alignment here. The whole presentation will be given to you. You can just go through that. If any doubts or design aspects, everything, whatever the doubt you get, you can discuss with me or our design consultant, Mr. Krishnakant. So the first one is the facilitating the work. You can hear the alignment. After alignment, this is the pre-construction activities. So with regard to the pre-construction activities, in the projects we do for the MORTH, Ministry of Road Transport and Highways, it is the responsibility of the state government to complete the pre-construction activities. Here in this project, because this flyover is running in the middle of the city, around 230 numbers of structures have been removed, spending an amount of around 115 crores from AP state government. And the removal of all these structures has been done in a record time of around 35 days, I tell you, in the year 2015. So these encroachments for 213 structures have been removed, land have been acquired, and the people who lost their full houses, they have been relocated some other place and they have been given houses also. All those process has been done without any court litigation in a record time of 35 days. The main thing is the encroachments of removal. Next comes here in the alignment, as I shown you before, the pump houses which pump the water to the city of Krishna, the city of VIJAYAWADA from Krishna river. So many pumping lines are there. So these pumping mains have to be shifted from the alignment. Around 700 meters of length of pipeline of the pumping main is coming in the alignment of the flyover. So that 700 meters pipeline has been shifted. This also has been done in a record time of 40 days itself. So rock has been encountered with while executing this shifting of pipelines, because you know the temple, KANAKADURGA temple is on the hillock, that is a rocky strata. So beneath also rock is there. So excavating into the rock and shifting of pipelines has been done. The other thing is HT towers have also been shifted. 3 existing HT towers have been removed and 5 new towers were erected in a record time of 2 months. Here, the first aspect of pre-construction activities has been done from our AP state government side. So next comes the flyover part. After pre-construction activities, next comes the flyover part. Here you can see this is a segmental construction. A segmental bridge is a bridge built in short sections, that is built in pieces. We'll do in pieces and then join them at the side and stitch them. So that is the way we construct a segmental construction. So the first precast segmental concreting bridge was built in the year 1962 across the Seine River in France. Just for academic purpose, this information has been given here. So we are more interested in our flyover here. So some of the key design points here I want to mention about our KANAKADURGA flyover, which made it iconic. Let me tell you, the width of the elevated flyover is 24.2 meters on a single pier. On a single pier it was constructed because of the space constraint. On a single pier 24.2 meters in a straight portion and 26 meters on a curved span, because the IRC specifies that in curved portion extra width has to be provided even on the road also, even to the flyover also. That has been implemented here. 0.9 meters on one side, 0.9 meters on other side, total it's 1.8 meters, 24.2 plus 1.8, 26 meters has been constructed on a single pier in curves. I told you 26 spans run in curves and 20 spans only are in straight portion. So this is very complicated alignment with 6 numbers of curves. I have shown you the curves also. Here you can see 6 curves are here. So because of the 6 curves is very much complicated. You can see some of these this type of flyovers. Only you can see the 2 of these such flyovers in India as of now. The third one is this one, and the fourth one is being constructed in Goa now. It's in progress now. So, but the other 2 they are very straight in alignment, but this is having 6 numbers of curves with a sharp curve of 160 meters radius. Very typical. Because of that, 65 kilometers per hour is the speed restriction given on the flyover. So alignment passes through Krishna River with bedrock presence. In the Krishna River we encountered with bedrock. So alignment passing through Krishna Eastern Main Canal and facilitating the vessels clearance for inland waters. Means Krishna Eastern Main Canal is a navigation canal. Navigation. As of now, the central government is encouraging the navigation. So for that purpose, I got it approved from the Inland Waterways Authority of India, Delhi. So there they put so many conditions that the spans have to be arranged in such a way that vessels, there should not be any obstruction for movement of the vessels in the canal. So container vessels. So for that, so we made we rearranged the spans and the piers and all those things, and we also made protection to the piers for the inland waterways. So that approval also has been got. So the other one is extended pier cap with 16 meters superstructure. This will come across afterwards. So this is a typical cross section. You can see this is a 24.2 meters in the straight portion, 24.2 meters at the top. These are the simple drawings we draw in AutoCAD. So students will be very happy to see this, I think. So it's the one simply we draw, and this is the one being implemented in this site. So you can see these are the crash barriers at the top in brown color, and below that green is wing. We call this the wing. In between yellow is the spine. Below that in pink color they are the bearings, and below that the pier and the pier cap, and below that the pile cap and the piles. So on both sides of the pier you can see this is the road construction being done, and on the both sides at the end of the road the trains have been constructed to a width of 2.5 meters.
Excuse me,
2.5 meters. Yeah, this is the typical cross section of the flyover that we constructed. So next comes the foundations part. So after a typical construction, the execution part is the piles. So here you can see, so we have executed the pile foundations that are 1.2 meters there, 1200 mm diameter piles have been driven into the ground. So 419 numbers of such piles have been executed in this project flyover. So these piles are both side friction and end bearing piles are encountered based on strata. When the rock is encountered with that will be end bearing pile. Yeah. So next is we have conducted lateral and vertical both static and dynamic load tests, and the lateral load tests have been conducted. I will show you the photographs afterwards in both soil and rock strata. Group of piles means below the each pile cap, how many piles are there? You will get that out. Minimum 8 numbers piles are there, and maximum group is 16 numbers. For some of the piers, we have to do 16 numbers of piles have been done. So depth of the pile is maximum of 40 meters. Depth of the pile is maximum of 40 meters. So next slide. So you can see here piling with rigs. This is the piling with rigs. At the same time, we have done piling with 9 rigs at a time. Continuously, day and night, the piling activity has been done. So on the right side, you can appreciate simultaneously the piling has been done with the winches. This was the old traditional way of doing the piling. However, when the rock is encountered with, I told you in the Krishna River, because on the right side is the temple pillar, and the strata of the rock is like this, and here it was done with the winches. So both with the rigs and winches, the piling activity has been done. So here you can see the static. This is the left one. You can see the static load test being done. This means seeing how the settlement is there, means seeing there personally. So with respect to the static load test on the piles, the right one is the dynamic load test on the piles, and in between we did lateral load test also on piles. So know that. So lateral load test has also been done on piles. So next one is one interesting activity. I'll just let you know. So here into the river we have constructed around 9 piers. For constructing the piles, for doing the piling and constructing the piers and pier caps, what we did here, we have done dredging operation in the Krishna River. Means dredging is the operation of excavating material from the water. So below the water sand will be there. So dredger will be kept here. So by dredging, the sand will be accumulated on the bank, and a bank has been established. And on that sand bed, what we accumulated, we did the piling. So this is one of the techniques that has been implemented here, dredging. So next comes above piles. It is a pile cap. So you can see here, this is the reinforcement, heavy reinforcement of the pile cap. So the pier reinforcement also will come there. So and after that, different shaped pile caps, because the group of piles is at sometimes 18 and increasing to 16, because of that the varying shape of pile cap has been constructed. The definitions of pile cap and all those things have been marked here. You can just go through that. This is the typical section both ways of the substructure. So these are the piles. Above that pile cap, this is the pier. Pier width is 2.1 meters on one direction, and it is varying from 2.4 to 3.4 on the other direction. So this is the slimmest pier. This also I tell you why it is iconic. In the other two flyovers, the width of the pier is not so slim as we constructed here. It is 2.1 meters width. So the pier cap is also very slim. So and above that, this is the spine, and on both sides of the spine, these are the two wings. So below the spine are the bearings, and above the spine this is the crash barrier. So the other side of the cross section has been shown here. So this is next comes after pile cap. This is the pier. So you can appreciate the workmanship here. Here the contractor has deployed a self-supporting pier shuttering. So here the shuttering, you will place the shuttering like this, and on the four sides the support bracings and all those things will be like this, so that no lateral supports are required to this shuttering. So by tightening of the four sides, it will be just like that, and you can pour the concrete into the pier. At a stage you can do is here, the full height of the pier has been done here. Actually the height of the piers is around 15 to 16 meters maximum. So it will be done in shifts. However, you can appreciate the workmanship here. So next is the pier cap above the pier. You can also see the slim section of the pier cap, very slim section here. The right side is the pier and the pier cap constructed figure. You can see. So here you can see the pier, how it is finished. So without any other finishing, because of the shuttering that is used, you can see how neatly it has come. So this is the grade of concrete, just to mention the grade of concrete we mentioned here. For piles and pile cap, the grade of concrete is M35. Pier and pier cap, it is M50. I girders, we have used at some locations I girders, that is M50. Superstructure, it is superstructure spine and wings, it is M60. M60 concrete has been used. EP pier cap M50. To get the required high strength of concrete, we have used admixtures, mineral admixture, silica fumes and alkafines, chemical admixtures, phosphoric Auromix 400. Those are the admixtures we used to get the high strength concrete. Here above the pier cap, we are having the bearings, as you know. So here we use the bearings are of part PTFE type. Bearings have been used. In this part PTFE type bearings, we used free bearings are used for vertical loads, and pin and guided bearings are used for horizontal forces. Pin bearing means not allowing the movement. Guided bearings, the other side, they will allow the movement of these slabs. So free bearings, they will distribute the total load of the superstructure onto the pier heads. So here in the right side, the placement of the bearings B1, B3, B1, B1, B2, B1. These are the bearings. B1, I will show you in the next slide. So these are the actual figures of the bearings. Free bearing is B1 at the bottom. You can see there. So B2 is the guided bearing. B3 is the pin bearing. Pin bearing doesn't allow the movement of the span. Guided bearing allows the movement, and free bearing it distributes the load onto the pier cap. So one more thing I want to mention here, why we have used these three types. You know, our spans are 3-span continuous. Other specialty of our flyover is our flyover is 3-span continuous. Means there will be expansion joints 1 in 3 spans. After 3 spans only we will be having expansion joints, but for not each and every span. Because of that, these 3 types of bearings have been used. So this is the casting of spine and wings construction methodology, just for your interest. So first of all, bending the reinforcement, case placing, and then crash barrier reinforcement, binding, then bulkhead, keeping of bulkheads to the spine, profiling, sheeting. Means for HD stands to run, we have to do the profiling, then concreting, deshuttering, curing and stacking. These are the consequential operations. So precasting of segments means, as I told you, this is a segmental construction with the spine and wings. The casting of segments can be done in 2 ways. That is one short line method, other one is the long line method. Short line method means in pieces, not connecting between 2 pieces, it will be constructed. Afterwards, they will be joined. But in long line method, replica of the span, what we do in the site, it will be done in the casting yard, and after doing that, the pieces will be separated, transported, and again placed as it is done in the site. I'll just show you in the next photograph how it is like that. You can see here, this is the bed. This is the bed of the spine. The right side, they are the constructed wings, the constructed spines. Next, when you see the next slide, so here what will be, you know, this is a P11 to P12 span. So actually, as all of you know, in curves, so the inside of the curve we have to provide it lower side, and the outside of the curve we have to provide it higher side for super elevation. So because of that, we will be taking the actual coordinates that are required, x and y coordinates that are required in the site over that 2 piers. So we will be calculating those coordinates, and those coordinates we will provide on this bed. You can see this is not uniform on both sides. It's varying. So using the adjustment here, it will be done just replica of that span. So after doing that, so the spines will be cast on this bed piece by piece. One piece will be casted first, and rushing to that next piece will be casted, and flushing to that next piece will be casted. Likewise, this is called a long line method. Bed continuously keeping long and doing replica of that required in the site. So this is a short line method. In each piece it will be done, afterwards they will be joined. This is not being done in our site. Next. So this is with respect to the superstructure. Superstructure is of spine and wing type PS segmental guided system. Wing to spine and wing to wing stitch concrete is provided. Means the spines will be attached and afterwards to spines wings will be attached and stitch concrete will be done. Like our shirt, this will be cut into pieces, afterwards stitching will be done. Likewise, between spine and between wing and wing also we will do the stitch concrete. So as civil engineers. So both internal and external cables are used longitudinally. Longitudinally means along the road, along the flyover. Continuous PS cables are provided transversely, means transversely also from one end of the wing to the other end of the wing also. PSC cables are provided and stressing done. So superstructure is of 3-span continuous with slab continuity. Means only in 1 in 3 spans we provided expansion joints. This gives very good riding comfort. So on 16th we are opening the flyover. So it's being opened by the Honorable Minister, Central Minister, and Honorable Chief Minister of AP. So afterwards we can see the facility on the flyover. Expansion joints are provided at every 3 spans. This is a segmental construction advantages: speed in construction, very economical for long spans. So very useful in land constraint areas where there is no sufficient land is available. You can do in pieces and then afterwards join by stitch concrete. So prefabricated segments provides more quality control. Means each piece can be done to the utmost quality. That every fraction, every piece of it can be done to the required quality. So this is the cross section of the superstructure spine and wing. This you can see the both diagrams. So spine and then wing on both sides, and crash barrier, edge crash barrier, and below that pier cap and the bearings, thin or guided bearings. So how the bearings are provided, it has been shown here. So this is I think some of the students might have prepared some drawings like this. So this is one such a drawing prepared by, I can say, one student. So that's being implemented here in the site. So here the cross section, here the yellow one is the spine, the green one is the wing, so red one is the central crash barrier and edge crash barrier. So here you can see in this cross section, this is a stitch concrete. This is a stitch concrete we did. So superstructure, some interesting details about the superstructure are in 45 meters span. Each span it weighs around 1438 metric tons. Including steel and concrete, it weighs 1430 metric tons. Weight of each spine varies from 41 to 60 metric tons. Weight of wing varies from 50 to 20 metric tons. The other reinforcement details for kgs per meter are also being given below. So this is a part of the superstructure. The spine which rests on the pier, we call it S1. First spine you can see here. So these are the holes for running the cables. So the cables, the total number of cables are 26. So number of internal cables are 18, number of external cables are 8. So what we'll be doing, first the internal cables will be stretched after keeping the spines in position over the ground supporting system. Internal cables will be stretched. After that, supports will be removed, and when after joining the wings and all those things, the external cables will be stretched. So this is the casting yard. So we gave a casting of about 21 acres to the firm to cast the spine and wing. So here the jigs you can see, the reinforcement, how thick it is, how dense it is, you can see. So this is the below are the diagrams of the rebar factory. Actually the firm installed a rebar factory where it is computer operated. So whole coils of steel will come there. So when you feed one diagram, design diagram of the syrup or anything, so and the number required, just it will straighten, shape it, cut it, and the whole numbers will be given in no time. So that is such type of factory has been established here. Next. So here this is in the long line method. You can see appreciate the casting of spines. The right side is the reinforcement of a single spine. You can see how much dense it is. So that's the reinforcement. So after casting these spines using the gantry cranes, there are cranes. This is you can see here. This is a gantry crane. So lifting the spine and placing for curing and stacking. So here casting of in the casting yard, casting of wings, placement of reinforcement. Here you can see the wings are done individually, not in attaching one by one. They are being done individually. So below is the casted wing. You can see. So here you can appreciate the casting yard that's been given to the firm. They have placed the wings and the spines in a two-tier system. Here wings one above the other, spines also one above the other. So before being transported to the site for placing. So here next comes the erection of the spines. After casting in the casting yard, erection of the spines is being done by ground supporting system. This is called ground supporting system. From ground we took the support, not the launching gantries or girders like that. We took the ground supporting system because so many curves are there. So for the curves it was thought that this will be better to use. So on this ground supporting system, each spine will be placed one, and the next one flush to it, next one flush, like that it will be done. So they will be transported from the casting yard to the site and lifted by using a 250 metric tons crane. So each spine will be lifted and placed. So this is another photograph. In curve also, spines is being done. Like a train, you can see here how they lifted and placed in between the piers. So next comes the erection of wings. So this is the erection of wings. So the spines, after doing the spines erection by GSS, and I told you the internal cable stressing will be done first. After doing that, the ground supporting system will be removed. Means the spines will be on their own. So above them, the wing launching beams will be placed. This orange color you can see here. So further the wings will be hanging here on both sides. Using my clay bath, they will be hanging. So right side also, the wings are hanging here. They will be in that hanging position. After that, so the alignment of wings will be done. Next comes. So here you can appreciate the beams, and below the beams the hanging wings. So all of the wings will be aligned to the required super elevation on both sides of the spine. So this is another photograph of the wings. Next comes, so after doing that, the stressing will be done. After doing the stressing, we will do the stitch concrete. So this is one wing, this is one wing. In between these two, reinforcement is there. So we will tie them. And after that, the bottom shuttering will be placed, and this stitch concrete will be done. This is called stitch concrete between wing and wing, and with that the whole span will be finished. You can see here. So here you can see the concrete between the spine and wing is finished. However, between the wing and wing is yet to be done. Alignment is perfectly done. Earlier they were uneven, top and down, top and down. The other side still to be done. You can see this side it is completely perfectly done. So now you can see here. This is a part of work has been done. Magnify that. You can see here. You can see. So here the spine and wings both completed. Here beams and below that wings, and here only spine completed. Here only beams are there. So different operations are here without spine and wings. So these different operations of the flyover being there. You can see here also. You can see only spine is completed here. Both spine and wing completed here, with beams over spines, with beams and wings hanging. Here, stitch concrete being finished. So that the different stages of activities. Yeah, you can see here the aerial view after the construction, aerial view after the construction of the flyover. So this is a temple hillock, river, barrage here, and all those things. So next one is extended pier. I'll just take 2-3 minutes. So here you can see this is the pier section which is 2.1 meters width. I told you. This is another pier here. In between two extended piers have been done. Generally, for a span of around 16.5 meters, means we generally execute that as spans of 16.5 meters. We provide two piers, one pier here, one pier here, and like simply supported, we will do this slab, and that will make that span. But here, the unique thing what we did here is a 16-meter span has been done on a single pier. 16-meter span has been done on a single pier. You can see this is a 16-meter span done on a single pier, not with two piers. You can appreciate that. So that is the specialty of this extended pier. 6 such extended piers have been constructed in this flyover to facilitate the traffic below, because these are constructed because at that locations extra pier could not be provided. For that purpose, we have done it as extended pier in Y shape. You can see their construction. So this is another one such figure being prepared. Some of your students might be. So it's being implemented here. This is the Y pier. Spine is also a part of that. Only to this green portion, we will attach the wings as we do in the normal way. We will attach the wings. So here you can see these are the wings being attached. Green one is the cash barrier. You can see this is the one cast in situ. These are the precasted elements for wings being attached to it. So this is the real execution of the wings, the extended pier, which was very tough in execution. I think around 120 metric tons of steel has been used in each of the extended piers, because this like cantilever portion you can see. So how it is being designed and done, you can appreciate. This is the one after completing the extended pier. Yeah, this is the one after finishing. You can see here. This is the extended pier. To this, so up to this portion, it is being done cast in situ. So beyond this, wings as done in the other spans, the wings have been attached. So this one is one extended pier. This one is other extended pier. The other are the normal piers. So here, just I want to tell you. So I finished the flyover part. Here, just opposite the temple. This is the what we call the GoPro of the temple. So earlier, before doing this project, this was the position. This is the wall of the temple. So the road was like this, around 7 meters. So the whole NHC traffic coming there, and congestion of the traffic, jams for about hours together there used to be there. So after doing the project, this is not at the level of the flyover. At the upgrade road, I am telling you. So we improved this road, and apart from that, we constructed a major bridge of 2 lane on the other side. So by giving a 4-lane configuration here, 4-lane facility at the entrance of the road. This is the before construction. This is after the construction. This is only major bridge. Apart from this, you can see this is the pier of the flyover during the construction stage. Yeah. So I'm finishing my presentation. This is the view of our flyover of Vijayawada. So you can see the other things. This is the VMC Vijayawada. Where the median width is more than 2 meters and so much median is available. They have developed some gardens and play places for anybody, recreation, all those things they have done. So everybody of Vijayawada is appreciating. You can see here the vertical garden being developed to the piers. That's also there. So here you can see the night view below the flyover, not on the flyover. This is the night view below the flyover. So this is one we did at the night time. So for lighting also, we have checked with respect to the lux value. Lighting means we check the lux value. So that lux value is checked. That is 40 lux is available.